Again, welcome back, guys. Warm-up number 8 is on the screen, and number 1 reads, simplify negative 2x plus negative 2y plus 3x squared plus negative 4x plus 6y plus negative 4x squared. For numbers 3 and 4, it says solve. 2 and 3, it says solve. Number 2 reads, 3 is greater than or equal to q divided by negative 7 greater than negative 6. And number 3 reads b minus 2 over 4 and equal to b plus 1 over 3. So I'll give you guys some time for that. Ready and go. All right, let's see where we're at. Let's look at number 1. Number 1. Let's see. How about Valerie? What'd you get for number 1? Negative 1x to the second minus 6x plus 4y. Hands if you got something like that. That is correct. Is it in standard form? Yes. Second degree, first degree, first degree. Yes. All right. How about number 2? What do you get for number 2? Solution set. How about Miguel? Solution set of Q such that, what else? Is that it? Okay. All right, so this is correct and this is correct, but we're still missing stuff. So if we were to draw a line down the inequality symbols, we need to leave q by itself. So what do we do to get rid of that negative 7 that's dividing? We multiply times negative 7. Multiply times negative 7. Multiply times negative 7 all sides. Is that correct? So that leaves us with negative 21. Since we multiply times a negative with the inequality symbol, flip it again, 42. So it should read solution set of q such that negative 21 is less than q, which is less than 42. Hands if you got something like that. Okay. Number 3, for the sake of time, let me go over this one. Since it has fractions, what was your common denominator that you multiplied by? 12. Okay. Now, common mistake on this one, look up. Some of you only multiplied times this, but since it's distribution, you needed to multiply times all the terms on the numerator. So be careful with that. So this is 12b minus 24 over 4 equals 12b plus 12 over 3. Simplify that. That gives us 3b minus 6 equals 4b plus 4. Get all variables to one side. I subtract 3b, subtract 3b. So we end up with negative 6 equals b plus 4. And from there we subtract 4 from each side. So we end up with negative 10 equals b. Hands if you got that? Okay, good. Now, let me show you another way of approaching this, and this only works, pay attention to this part, when we have a fraction equal to another fraction. When does it work? When we have a fraction equal to another fraction. Look what I'm going to do. When we have a fraction equal to another fraction, all I have to do is cross multiply. So watch. What is 3 times b minus 2? That is 3b minus 6. Equal. What is 4 times b plus 1? 4b plus 4. Don't I have the same thing as here? And from there, we know what to do from there. So those are 2 different approaches. Just keep that in mind when we get to some of those proportions. This is what we call a proportion. Okay? Yes, Mr. Q. Copy the agenda, please. Today we have warm-up number 8, absolute value equations and inequalities. We're continuing on today. And your home plate for tonight is also another play sheet with only 10 problems. Only, yeah. You guys catch that pretty good, yeah? And as soon as you're done copying that, make sure you get a Cornell note ready for today's notes, please. Once again, warm-up number 8, we just finished. We're still on absolute value equations and inequalities. And tonight's home play sheet with 10 problems. All right? Yes? Now, for those of you who are watching online, guys, today I don't have a code for you just because of the fact that Nearpod is taking forever to load. I've been loading since 7:30 this morning, and it's still thinking. I don't know what's going on with the program. So, for this video, just watch the video, take notes, and follow along as best you can. All right, and get your home plate from last night out, please. And this is what I want you to do. I want you to go over number 8 and number 9 with your neighbor to see if they have something similar to you. Make sure they got all the processes correct, solution set, and graphs. I'll give you some time. Go. So once again, those of you that are online, make sure you turn that in as soon as you're back from wherever you're at. If you're a Power Ranger, then, see me pretty soon. Your home plate for tonight, can I get the last person on each row? Go get a play sheet over there on the iPad cart for your row. It's only 10 problems. And the rest of us get a Cornell note ready so we can get started with our session. We're going to go straight into our session, so copy the objective at the bottom left. Bottom left. Give you some time to set that up. All right, here we go. Our objective for today, I can solve one-variable equations and inequalities. Once again, I can solve one-variable equations and inequalities by looking at it. What is our main concept for today? One-variable equations and inequalities. You write that in your prayer model, and we're still solving. Okay, we're going to continue on today. So in your prayer model, one-variable equations and inequalities. Once again, without looking at your notes, write a definition in your own words, one example, one non-example, and one hashtag. Especially those of you that are watching on video, see if you can do that without looking at your notes. I'll give you some time. Go. So, here it goes. It should be on your screen. Let's see. Hopefully you wrote something like that, or at least some examples, non-examples like that, and then your hashtag. Yes? Yes, Mr. Q. And then I gave you guys some steps when we started with equations and inequalities, where we simplify, isolate, plot, and check. Is that correct? Have we been doing that? Yes. And very intense because I'm asking you specific for solution sets. However, yesterday I gave you 3 specific steps for absolute values. The first one is to isolate the absolute value by itself. Second step, to write 2 equations without the absolute values. And then solve. From there we graph and wrote our solution set. You're going to have plenty of practice at home, so hopefully that'll help. Today we're moving on. But we're going to do something similar, so we're going to need these 3 steps. And you're going to see how all the practice that we did this past is going to make sense today in regards to how we add that to today. Ready? Here we go. Oh, just double check. Everybody remember what absolute value is? A number away from 0. And we said that the symbols, we get them from here to there. And what do we get anytime that we substitute values inside of the absolute value? What do we get out? It's positive numbers, because absolute values are distances, and they can only be counted as positives. Copy this, please. Example 1. Oh, my bad. Recap. Absolute value with 2 solutions is when we have an absolute value equal to a positive, yes? Absolute value with 1 solution is when we have an absolute value equal to 0. And absolute value with no solutions when we have an absolute value equal to a negative. Okay? Copy this, example 1. And it reads, solve the inequality and graph the solutions, and we have absolute value less than or equal to 2. Just copy it. I'm going to go over the entire process. All right, so hopefully the routine that we're getting into in regards to when I ask you to put your writing utensils down, it helps you kind of like ease from taking notes and just stay focused. because it serves a purpose. I want you guys to stay with me during the example. Are we there? All right, writing utensils down, look up to the screen. I'll ask you to copy once I'm done with the example. I want you to make sure that you understand the entire process. Ready? Here it goes. So I'm going to treat the inequality symbol as if it was an equal sign. Okay. So if I start with step 1, is the absolute value already by itself, isolated? Yes. So at that point, I would write 2 equations. So today, I'm going to write 2 inequalities. One for -2. And one for +2. Now check this out. So for +2, I'm going to write my inequality symbol and whatever's inside the absolute value. For the negative, the same thing, but look. Tell your neighbor what just happened. Why do you think I did that? Talk it over to your neighbor, please. Why do you think I did that? Oh, good conversations. Noor, why do you think I switched the inequality symbol for the negative? It turned negative. How can I turn a positive number into a negative? Either multiply or divide by -1. Did I show that step? No, I did it in here. So since I multiplied or divide by a negative to make it a negative, that's why we switch the symbol. Next, I'm going to solve. +1 + 1, x greater than or equal to -1. Look at this one. +1 + 1, x less than or equal to 3. Copy that, please. All right. Next, graph. Let's graph this together since we already know how to graph inequalities. I'm going to draw my number line right here. Draw yours right there as well. My 0. All right. Let's graph the red one first, yes? My dividing point is at -1. Okay. Does it have an equal sign here? Yes, there it is. So it's a solid point. All right. Next, I'm going to test what number? 0. Is 0 greater than or equal to -1? Yes, that is true. So I'm going to shade towards 0. Let's go to the next one. We start at 3. Is it a solid point? Yes, it's got an equal sign, so a solid point. I'm going to test 0 again. Is 0 less than or equal to 3? Yes, that's true, so I'm going to shade towards 0. What do you guys notice? They overlap. Now, I mentioned this. However, here goes again. Whenever they overlap, these are known as and inequalities. And inequalities. Are we done? No, Mr. Q? No, we need the solution set. So check this out. I'm going to show you an easy way of writing the solution set for these, specifically the ones that overlap like this. Watch. Solution set of x, writing utensils down, look up, such that, ready? I start with my dividing points. What variable do I use? X, that goes in between. Arrows are always to the left. And then check if these are solid points, then you put an equal sign, and we're done. Copy that, please. You're like, that was easy, right? Like that button, that was easy. No? You guys remember that button? No? So that was it, yeah. So as you're finished copying that, here goes the process one more time. We have an absolute value. There's nothing around it, so that means we write 2 inequalities, one positive, the inequality symbol stays the same, one negative, the inequality symbol switches. We solve each one, we graph each one, and we write our solution set. All right, I'm going to give you one to see how you do by yourself. Ready? Example number 2. Copy this. Example 2 reads, solve the inequality and graph the solutions. We got absolute value of x plus 3 less than 8. I'll give you a head start, see if you can do that one all the way through. Ready, go. Alright, so some of you are checking already, and here goes again just to make sure we got it. Line down the inequality symbol. We write two inequalities, one for -8. We flip the inequality symbol and we have x plus 3. That's a negative here. And one for the +8, which is x plus 3. The inequality symbol stays the same, and that is 8. From there we solve each one. -3 minus 3. X greater than -11. And over here, -3 minus 3. X less than 5. Hands if you got it to right there. Okay, good. There goes the graph. 0. I'm going to graph this one first. -11 over here. Open point because it doesn't have an equal sign. I'm going to check with 0 in here. Is 0 greater than -11? Yes, that's true, so I'm going to shade towards 0. Next, 5 is somewhere over here. It doesn't have an equal sign, so it's an open point, and I'm going to check to see if I shade towards 0. Is 0 less than 5? Yes, that's true, so I shade that way, and what do we find out? That this is an AND. So, solution set of x such that -11, 5, x, arrows to the left, and since they're open points, no equal signs, and we're done. Show me your fingers, how come you are with these? 1 being the lowest, 5 being the highest, 5 fours, 5 fours, okay? Shall we continue? All right, here we go, example number 3. Example number 3 reads, absolute value of x, then outside we have plus 14, greater than or equal to 19. Let's do this one together. Line down the inequality symbol. And let's see who can get us started. How about Sandra? What do I do there? Subtract 14 to each side. Thank you. We're left with absolute value of x greater than or equal to 5. Since we have the absolute value already by itself, we write two inequalities, yes? One for -5. We switch the inequality symbol. And what's inside of the absolute value? X. One for +5. And the inequality stays the same. And we have x. Step 3, can we solve? Oh, it's already solved, Mr. Q. All right, so this is our solution here. And this is a solution over here. So let's graph this. Alright, it's kind of crooked. There it is. Alright, so here's 0. Alright, I'm going to start with this one. -5 is over here. Is it a solid or open point? Solid, because it's got an equal sign. Okay, then I'm going to test 0. Is 0 less than or equal to -5? That's false. That is not true. So I'm not going to shade towards 0. I'm going to shade in the opposite direction. Next, 5 is over here. Has an equal sign, so it's a solid point. And see, let me see if I can shade towards 0. So I'm going to substitute 0 in here. Is 0 greater than or equal to 5? That's also false. So I'm not going to shade towards 0. I'm going to shade in the opposite direction. And what kind of inequality do we know these are? Or. Label that. So like that you know that it's an or. Now check this out. This is probably the easiest one that we can think of in regards to writing our solution set. Look up. What was our final solution here before the graph? These two, yes? So watch. All I do is solution set of x such that, what's my first one? X less than or equal to -5. Then we write or, and then x greater than or equal to 5. Let's go. How are we doing? Yes? All right, from 1 to 5 so far. How are we doing? 5, 5, 5, 5 fours. Okay. Yeah, good. Do another one? Yes? Let's see how you do with this one by yourself. Example number 4. It reads 3 plus then we have absolute value of x plus 2 greater than 5. I'll give you some time for that. Copy that in. All right, so as you're sharing, I'm going to go over this just to make sure we got it. Line down the inequality symbol. First things first, you should have noticed that the absolute value has a 3 outside of it, so that means we need to subtract 3, subtract 3. So leave it by itself. We're left with absolute value x plus 2 greater than 2. Hands if you got it to right there. We're good? Since the absolute value is by itself already, we write two inequalities, one for negative 2. We flip the inequality symbol and we write x plus 2. Don't forget about that. This is negative. One for positive 2, the inequality symbol stays the same, and then we write x plus 2. From there we solve each one, minus 2 minus 2, x less than negative 4. And look at this one, minus 2 minus 2, x greater than 0. Hands if you're up to there. Okay? Graph. All right, so I'm going to start with negative 4, which is right there. No equal sign, it's an open point. I'm going to test 0 to see if I shake this way. Is 0 less than negative 4? No, that's false. So that means I'm going to shade in that direction. Next, 0. Open point. I'm going to test, wait a minute, I can't test 0. So what do I test? Negative 4, okay. Negative 4. Is negative 4 greater than 0? No, because 0 is more to the right, so that means this is false. Well, I don't shade towards negative 4, I shade in the opposite direction. And what do we notice? It's an OR. So from here, we go with our solution and write solution set of x such that x less than negative 4 or x greater than 0. Let's go. Too easy. Right? Am I right or am I right? This reminds me of me in kindergarten. I don't know what it is. Anyways, so check this out. I want to show you something, and I'm going to use the force. Ready? I'm not going to play any music. I'm not going to say anything. I'm going to show you something. So I need your eyes on the screen. Ready? Here it goes. Talk it over to your neighbor, see what you saw. Right? You know what I'm saying? I'm telling you, it is what it is. So, check this out. So what can we conclude? If we have absolute value inequalities, and the inequality is pointing left. What kind of inequalities are these? And if we have inequalities, absolute value inequalities pointing with the inequality to the right, we have OR. So therefore, copy that please. And underneath these, you're going to write and underneath these, you're going to write OR. Just so that when you're doing your home play or you're having a pop party and then you end up with stuff like this, you make sure that your graph matches what you anticipate. So these should be and, that means that the graphs are overlapping. And the other ones are or, so that means that the graphs are going in opposite directions. Mm-hmm. Yes, Mr. Q, these are my favorite. All right, good. All right. We good? Yeah? All right. I have two more things to show you. So copy this next example, please. It's 2 examples in 1. Okay, copy this. Example super Q. Part A says solve the inequality, and we have absolute value of x plus 4. Then we have minus 5 greater than negative 8. Part B reads solve the inequality, and then it reads absolute value of x minus 2. Then it says plus 9 less than 7. Just copy it, and I'm going to elaborate on this with you. All right. Writing utensils down, look up to the screen. Here it goes. Okay? I need you to be with me so you can think this through, because these are special situations that we are going to encounter. So here we go. I'm going to start with this one. To leave the absolute value by itself, what do? Add 5, so we end up with absolute value x plus 4 greater than negative 3. Isn't that a red flag? It's a negative number, is that correct? So let's think this through. What do we have on this side in absolute value? What did we say absolute values were? The distance from 0? And we can only count in positive. So that means it doesn't matter what's in here, we're always going to get a positive. Is that correct? But here we have an inequality that says that positives are greater than negative. Is that true? Let me repeat that again. Are positives greater than negative? Yes, they are true. Now, does it matter what I substitute in here? Will we always get a positive? Yes, doesn't matter what I substitute in. If I substitute a 1, what is 1 plus 4? 5, so we should get a positive 5. If I substitute a negative 2, what number do I get? 2, yes. So substitute a negative 10, that's negative 6, but then what comes out? A positive 6. So far so good? So it doesn't matter what I substitute. Everybody agree with that? So guess what? Whenever you encounter these where you have an absolute value greater than a negative, that means that my solution set is x such that, check this out, x is equal to this symbol, which means all real numbers. Because it doesn't matter what I substitute in here, this will always be what? True. Copy that, please. You're like, what? Bless you. I know, right? Fun stuff? Yes, Mrs. Q. Good. So far so good. Okay, let me go over this one. Writing utensils down, look up to the screen, check this out. To isolate the absolute value, I need to subtract 9. We're left with absolute value of x minus 2 less than negative 2. Another red flag. Well, let's think this through. What comes out of an absolute value? Are positive numbers less than negatives? No. So if it doesn't matter what I substitute in here, if it's not true, what would you write? Talk it over here. What would you write if that's not true? Let's see. What do you think, Raymond? Let's go. No solution. That is correct, because it doesn't matter what we continue substituting, it's still not going to be true. This would be false. And I don't know if you guys saw my artistic skills. You guys see that? Let's go. So what can we conclude with absolute values? That if the absolute value inequality is pointing to the left and we have a positive number on the right, it's an AND. If the absolute value is pointing to the right and we have a positive number, it's an OR. And what can we conclude with these with negatives? If the absolute value is pointing to the right and it's a negative, it's all real numbers. And if the absolute value is pointing to the, the inequality is pointing to the left and we have a negative, it's no solution. We good? All right, show me your famous outcome VR now that we completed absolute values. 5, 5, 5, 5, 4, 5. Okay. So, I'm going to stop the recording right here. So those of you that are online, make sure you get to your home play as soon as you can. I'll see you guys till later. Peace.